Hi students, I just wanted to send you a video for, of course, this week is the start of Unit 2. And we're going to be talking about inductive, deductive reasoning and why do we need it so much? How does it apply to what we're studying this unit? Well, I wanted to show you some flashcards because I think the best way to learn inductive and deductive reasoning is to look at multiple examples. So, let's start with this example. I actually found it on Quizlet. This is Quizlet.com. These are flashcards for deductive and inductive reasoning. And feel free to go to this exact website and start practicing what it means to have inductive or deductive. We're only going to do just a few of these, but I just want you to get used to the problems and what it looks like. So it says the Giants have lost their last 7 games. Thus, they will probably lose their next game. Is this inductive, which is based on patterns, or deductive, which is based on logic? What do you think? Inductive or deductive? And over here you can click to flip. I think it's inductive. There we have it. Let's go to the next one. It says if you brush and floss your teeth daily, then you will have fewer cavities. Marie brushes and flosses her teeth daily. Thus she will have fewer cavities. What do you think? Do you think it's based on patterns, inductive, or based on logic, that if she brushes her teeth every day, she'll have fewer cavities, so therefore she brushes them daily, and there she will have fewer cavities? Inductive or deductive? Let's find out. It is deductive. It is deductive. Okay? Let's keep going. Jones will play tennis today if Smith plays. Jones will not play tennis today. Thus Smith will not play. So is this a pattern, or is this just basic logic that because Jones won't play, Smith won't play? Let's see. I'd say deductive. It is deductive. 4 out of 5 times I beat Corey at pool, and I'm going to play him tomorrow. So I'll very likely win. Deductive or inductive? Do you think that because of the pattern 4 out of 5 that he'll beat him tomorrow? Or do you think that there's logic involved, which is why it's possible that he could win? Inductive or deductive? I say, what do we say? Let's see. I say inductive. And it is inductive. The next one. If Bush's popularity goes below 20%, then he'll be forced to cut and run from Iraq. But that's not the case now. If Bush's popularity goes below 20%, then he'll be forced to cut and run from Iraq. But that's not the case now. Is this based on a pattern, or is this based on logic? Do you see a pattern in this sentence? If you don't see a pattern, then do you see logic in this sentence? I do. I see it as deductive reasoning. And it is deductive. Let's keep going. No man has ever gotten pregnant. Thus, no man will ever get pregnant. Inductive or deductive? Is it inductive based on pattern, based on the pattern that no man has ever been pregnant? Or is it based on logic? Is it based on logic? No man has ever gotten pregnant, ever being the key word, thus no man ever will get pregnant. So inductive or deductive? My vote is on inductive because I believe that based on the pattern that no man has ever had a baby, I don't think they'll have one in the future. So therefore, in establishing a pattern of there will be no babies. So I say inductive. And it is inductive. Let's keep going. Most people are pro-choice on abortion. At least most of the people I know. Most people are pro-choice on abortion. At least most of the people I know. Are we talking about inductive based on pattern? Or are we talking about deductive based on logic? Inductive based on pattern. Because remember, this person is saying at least most of the people I know. Not the people you know or somebody else knows. At least the people, most of the people I know. So there has been some type of pattern established based on how many people this person asked. We don't know how many people they asked, but however many there was a high likelihood that most people are pro-choice based on pattern. So let's see if we're right. Is it inductive? It is. Let's try next one, number 8. John is a heavy drinker. After all, he's Irish. John is a heavy drinker. After all, he's Irish. Is there a pattern between being a heavy drinker and being Irish? Or could this be logic? Because he's a heavy drinker, he just has to be Irish. Inductive or deductive? You think there's a pattern here? And if there's not a pattern here, do you think there's logic? Think about it this way. When the words after all comes into play, it starts with John is a heavy drinker, and it relates it to, after all, he's Irish. So there is logic there. It is deductive. Okay, let's keep going. It has been observed that earthquakes precede the eruption of volcanoes. Thus, let's go back. It has been observed that earthquakes precede the eruption of volcanoes. Earthquakes precede the eruption of volcanoes. Thus, earthquakes cause volcanoes to erupt. Is this a pattern that earthquakes precede the eruption of volcanoes? Or is this logic that earthquake precedes the eruption of volcanoes? Inductive or deductive? I would have to say inductive, based on the word precede. It is inductive. Okay? 6 schools in other countries that favor year-round school have higher test scores than the U.S. in math, science, and geography. Therefore, the U.S. should have year-round schools. Inductive or deductive? Is there a pattern within these 6 schools? Well, obviously, because these 6 schools seem to have similar results because they favor year-round school and they have higher test scores than the U.S. Now, remember, the U.S. doesn't have year-round schools as a whole. There are some, but there's not a whole lot of them. So as a U.S., say, for example, most schools are on a 9-month schedule, 10-month schedule. So if these 6 schools have higher scores based on year-round and we only go to school for 10 months, is it true that the U.S. should have year-round schools so that they can have higher test scores? Inductive or deductive? Inductive or deductive? I'm going to say inductive. Let's see if we're right. It is inductive. Okay. We're going to go all the way to slide 15 and stop, and then we'll move on to other information. All students go to school. You are a student. Therefore, you go to school. All students go to school. You are a student. Therefore, you go to school. Is this inductive based on a pattern or deductive based on logic? Well, it says all students go to school. You happen to be a student. Therefore, you will be in school. You'll be going to school. So is this a pattern or is this logic? Is there a pattern or is this logic? Well, I believe this is logic because the fact that all students go to school, the obvious logical reason is if you're a student, you're going to go to school as well. So my answer would be deductive. There we have it. All birds can fly. An ostrich is a bird. Therefore, an ostrich can fly. Inductive or deductive? This sounds a little bit similar to the problem that we just did a second ago. All birds can fly. An ostrich is a bird. Therefore, an ostrich can fly. Is this inductive or deductive? My vote is on deductive because an ostrich is a bird and it can fly. It is deductive. Okay? To graduate from school, a student must earn 20 credits. Sal will graduate next month. Therefore, Sal must have earned 20 credits. Similar to the problem that we just did just a second ago. Actually, the last two problems. To graduate from school, a student must earn 20 credits. Sal is graduating. The assumption is that he has 20 credits. Therefore, it is deductive reasoning. It is deductive. Okay, two more to go. Rufus and Rose came back from the beach with sunburns. It must have been a sunny day at the beach. Rufus and Rose came back from the beach with sunburns. It must have been a sunny day at the beach. So is this based on a pattern or is this based on logic? Is this based on a pattern or a logic? Well, think about it this way. If you go to the beach and you get sunburns, can you just get sunburns from just being at the beach? Can you just get sunburned without the sun? Of course not. So if Rufus and Rose came back to the beach with sunburns, that means it had to have been a sunny day at the beach. Therefore, establishing a pattern. It's a sunny day, people go to the beach, therefore they get sunburned. So it is inductive reasoning. All right, last one. 5 of the 20 students surveyed liked the new dance policy. Those 5 were from the senior class. The senior class likes the new policy. 5 of the 20 students surveyed liked the new dance policy. Those 5 are from the senior class. The senior class likes the new policy. So can we assume that based on those 5, that the entire senior class likes the policy? Could we assume? Now, mind you, we don't know what those other 15 students are. We just know these 5 are from the senior class. The senior class likes the new policy. Is it inductive based on a pattern or deductive based on logic? I believe that there's a pattern going on with these 5 students. And could it be possible that if another 5 students from the senior class were surveyed, that they would like the new policy as well? So I believe this is inductive reasoning based on those 5 students from the senior class, and the senior class likes the new policy. All right, there we go. We have inductive reasoning. All right, let's move on. Inductive reasoning, we talked about patterns, but now let's actually do some actual problems on those patterns. All right, we have 3, 6, 9, and 12. The pattern is what? 3 plus what is 6? It should be 3 plus 3. 6 plus 3 is 9. 9 plus 3 is 12. What's 12 plus 3? Anybody know? What about 15? And 15 plus 3 is 18. 18 plus 3 is 21. This is what we mean by inductive reasoning. We're talking about reasoning based on patterns. 4, 8, 12, and 16. This is a pattern of what? Think about it for a second. It's a pattern of... This is a pattern of 4s. So 16 plus 4 is 20. 20 plus 4 is 24. 24 plus 4 is 28. Okay. Now, 10, 100, 1,000. 10 times what is 100? Should be 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. Okay. 19, 38, and 57. 19 times what is 38? Well, of course, 19 times 1 is 19. 19 times 2 is 38. 19 times 3 is 57. 19 times 4 is 76. And 19 times 5 is 95. Okay, so there's your review on inductive reasoning as it relates to patterns. Now, we're going to mix it up. Are we talking about deductive or inductive? Okay? I do not like big dogs because they bark a lot and it makes me scared. So when I see a big dog, I run away. Logic? or pattern? Logic or pattern? Inductive or deductive? Inductive or deductive? I do not like big dogs because they bark a lot and it makes me scared. So when I see a big dog, I run away. There's a pattern there. Inductive reasoning, because every time I see a big dog that barks, I'm going to run. Okay? Every second day of the week, I go to visit Katie. Is that a pattern or is that logical? Well, think about what's being said every second day of the week. I go to visit Katie. So there is a pattern. I had 8 fish and they died. I got my fish from Walmart. If I get more fish from Walmart, they will die too. Is that inductive or deductive? It should be deductive. The assumption is if I get more fish from Walmart, they will die like the rest of them did. Cammie loves cheddar cheese. Every time we go to the store, she buys cheddar cheese. Is that a pattern or logic? Read through the sentence to see if a pattern is established, and then read through the sentence to see if logic is established. Well, think about it. Every time she's buying cheddar cheese. So the pattern is inductive. I love red shoes, but recently I bought a pair of red and white shoes. I love red shoes, but recently I bought a pair of red and white shoes. Is that a pattern? Or is that just logic? Well, think about what's being mentioned. I love red shoes. I bought a pair of red shoes, even if white is included. That is an established pattern of inductive reasoning. I buy almond milk almost every other week for my smoothies. I am lactose intolerant, so I cannot drink whole milk. Inductive or deductive? Take a moment to think about that. I buy almond milk every other week. This establishes a pattern because I happen to love almond milk. Okay? Any questions? Any questions? I know some of these could kind of go either inductive or deductive, but it just depends on how it's read, and it's based on, is there a pattern or is there logic? Okay? Questions or concerns on inductive or deductive? All right, unit price. Unit price. Let's talk about unit price. Unit price occurs where we buy, say for example, items in bulk. We get a total, and then we divide that total over the amount of things that we received. Okay? For example, I just got 5 bananas for $1. How much is each banana? Okay? So let's go to our trusty little calculator. $1. And of course that's excluding tax and everything else. $1, divide that by 5, because I bought 5 bananas. How much is each banana? Each banana is worth 20 cents. And when we're talking about money, make sure you list that money sign right next to it, because if you don't, we're just going to think you're talking about 0.20 without the cents. So make sure if we're talking about money that you put that monetary sign out front, dollar sign. All right, I bought 8 apples for $2. How much is each apple? Okay, now of course, in most cases, you're buying these in a bag. So there's a bag of 8 apples for $2. How much is each apple? So you go to $2. And you say, I bought 8 apples. So let's divide it over 8. You have paid 25 cents per apple. Okay? You just bought a pair of shoes that, of course, you absolutely love because they're $120. How much is each shoe worth? Now, remember, we didn't talk about a bulk of shoes. We said a pair, and a pair is 2 shoes. Okay? So, If you bought a pair of shoes for $120, let's pull our calculator back out. 120. Divide that by 2. And we get 60. How much is each shoe worth? $60. Because in order for you to get a pair, you had to do 60 times 2 to get 120. All right, your grocery bill is $200. Many of us are experiencing the increase in grocery bills wherever we buy our groceries. Why? Because the market is going up for groceries, so therefore we pay more for our groceries. So your grocery bill is $200 and you bought 10 items in the store. How much is each item worth? Remember, your grocery bill is $200. The assumption is that it includes tax. But you bought 10 items in the store. How much is each item worth? Well, you pull out the calculator. 200. Divide that by 10. You have approximately paid $20 per item. Now, is that actually true? Maybe and maybe not, because we don't know how much each item was in your grocery bill. The assumption is that because you bought 10 items, the value is at least $20. But that could change based on the cost of each item. Okay? Now, let's talk about graphs and tables, because we use them a lot. And because we use them a lot, well, there is a significance in price. Okay? Since we are at Galen College of Nursing, every single semester, you have to buy school supplies. What does that mean? That means money goes out of your expenses or out of your account in order for you to pay for supplies. You need textbooks. You need notebooks. You need ink pens. You need pencils. Some people may need colored pencils. Some people may need exam materials for their nursing classes. All of that equates into a cost. Okay? Now this rising cost of school supplies is for students that are, say, K through 12. So this is looking at the school year of 2000 and 2005, and it's saying that between that time period, school supplies has gone up astronomically. So in 2000, school supplies were $21, but in 2001, it increased to $32. So the question is, between 2000 and 2001, how much was the increase in school supplies? The way to find that out is you just put in 32, you subtract it from 21. Because it's increasing, you always put the larger amount first. Okay? So 32 minus 21, school supplies has increased $11 between 2000 and 2001. That's a lot of money. Okay, especially if you have more than one kid. So now let's keep going. Between 2001 and 2002, it's gone from 32 to 46. Well, how much of an increase is that? Well, you take 46 and you subtract it from 32. It's gone up now $14. So between 2000 and 2001, it's gone up $11. Now it's gone up $14. Okay? Now, between 2002 and 2003, it's gone from 46 to 56. Well, we can figure that out. That's just what? That's just $10. So far, so good. It looks like the cost is going down. All right. Between 2003 and 2004, you can notice there's a pretty nice sized jump there. Pretty nice sized jump. Okay? Now, again, we're talking about parents who have more than one child in school. It's jumped from $56 to $78. That's a lot of money. But how much of an increase have we had? Well, let's see. 78 minus 56 equals $22. That's a lot. It's actually quite a lot. And I would love to know how many school supplies is actually in there in order for it to increase $22 in just 1 year. And now let's do between 2004 and 2005. It's gone from 78 to 92. So let's subtract 92 from 78. That's an increase of $14. Okay? Now let's look at the pencil chart as a whole. How much increase have we experienced between 2000 and 2005? Well, we start off with the largest amount, which is 92. And we subtract that from the smallest amount, which is $21. This is an increase of $71 between 2000 and 2005. Imagine if you had to buy school supplies during this time. Think about it. You'd be out of a lot of money because every year school supplies go up. You want to know why? Because school suppliers know that parents need a certain amount of school supplies. They need certain things for their kids to go back to school. And even if they are going back to school, it's an even higher cost. Okay? Because for adults to go back to school, we have textbooks and all this other kind of stuff. But even for children, this is a lot of money. Okay? Let's look at another chart. Charts can be described in many different ways. We just saw an example of a bar chart, okay, where it's going up or it's going down or it's a little bit in the middle. Now, most types of charts are either bars, lines, or pie charts. Pie charts represent a percentage of 100% as it relates to the items that you are told to configure. All right, let's keep going. Let's talk about another bar chart of snacks. Okay, so we're looking at snacks, and we're saying popcorn, crackers, trail mix, cheese, vegetables, and fruit. You have children who want wonderful snacks. So, of course, they have a chance to pick what snacks they want. So, if you were to pick the top 3 snacks, from this graph, what would you pick? Take a moment to look at the chart. The top 3 snacks. Between popcorn, crackers, trail mix, cheese, vegetables, and fruit. Okay? Number 1, number 2, and number 3. What do you pick? Well, the first choice would be fruit, because fruit has almost 9 votes. Okay? So fruit is answer choice number 1. All right? What's the second largest amount of votes? Cheese is the second amount of votes because it has 7 votes. What about the third option? What does that look like to you, the third option? It looks like we have a tie between popcorn and vegetables. Okay, so since we have a tie, let's take out those. And let's go with the top 2, fruit and cheese. Okay? So we got 9 votes for fruit and 7 votes for cheese. Okay? Now, in this chart, we don't know if anybody voted more than once. We don't know all of that. But we do know that fruit has 9 votes and cheese has 7 votes. So if I were to go to the store and get fruit and cheese, a large amount of students will eat fruit and cheese. Now, does that mean that's all they'll eat? No, because I could very well go to the store and get all 6 of these items. And the people in the class are going to eat what they want to eat. Okay? All right, let's keep going. Grades in math and number of hours of TV. Now, we've all talked about television and its effect on learning and is it positive and so on and so forth. So, let's look at this chart. And let's look at inductive reasoning as a pattern. And then we can look at deductive as logic. So inductive says, is there a pattern here? So this is the amount of hours of TV. This is the amount for grade level. Okay? So inductive reasoning says there's a pattern. Is there a pattern here? Well, I'm looking at A is here, B is here, C is here, D is here. Okay? This could actually be a chart that does a little bit of both of inductive and deductive. So if I say A has 8 hours of TV, B has 13 hours, C has 15 hours, D has 16 hours, then I'm saying there's a pattern being established here through inductive reasoning. But I'm also saying, A doesn't have a whole lot of hours of TV, but actually has the highest grade in the class. D has the highest amount of TV, but actually has the lowest amount in the class. So I could concur that the more hours of TV that a person watches, the lower their grade will be in math. Okay, and of course you'd have to do that over multiple students in order to determine if that's true. Okay, well, we're wrapping up. If there's any other questions, let me know. I hope you enjoy the rest of this time in this particular section. If you have any questions at all, feel free to email me. I have my email as well as my Canvas inbox in my phone, so I'm able to give instant responses, of course, before nightfall. The last response that I normally send is no later than 10 o'clock. So if you have questions or concerns, feel free to let me know. Have a great rest of the week.